Broadcast is now starting. All attendees are in listen-only mode.
Everybody, we'll let everybody else hop in here really quickly, and we will get started. All right, looks like we're all here. I want to thank you for attending our webinar on vegetating difficult soils. My name is Lauren Alanis. I am the Director of Sales for ECB Verdyol. We manufacture a topsoil replacement product, soil improvement product by the name of Biotic Earth. And so we'll talk about how using a product similar to that can assist in revegetating some of the difficult soils that we find often on construction sites. So we'll go ahead and get started here. I'll go ahead and kick this out. There are a couple things before we get started. If you do have questions as we go along, feel free to drop them into the chat or question field. I'll try to answer them as we go along. If I don't get to your question, we will have some time for question and answer after the webinar. And then also, you will notice there are some handouts there. Those are some case studies and some design parameters on use of our product that you can download if you would like as well. If for some reason you can't download those, you can email us after the webinar and we'd be happy to send those to you. So we'll go ahead and get started, and thank you again for attending our webinar. So when we talk about revegetation, it really is a concern regardless of what your project type is. If we are in talking about municipal projects, DOT projects, oil and gas projects, private projects, even just residential, we are all going to face the same issues of restoration, revegetation, or possibly reclamation before we can close that project out. Sometimes, depending on our soil conditions and climates, that is easier to do than others. You know, but one thing I think we should start thinking about more in this industry is not just closing out those permits, not just closing out those projects through initial germination. We measure this success on our projects by getting to 70% cover, and then we're able to close out our projects. But it's not about just getting something to germinate, because truly we can get vegetation to grow on anything short term. It's how successful is it going to be long term? How successful is that vegetation going to be season after season, year after year? And so it's sustainable vegetation that we should be focused on trying to achieve on our sites. And that has proven to be quite elusive for us in the industry. But it definitely is something that we need to pay more attention to, because vegetation is not there just to be aesthetically pleasing. It is there to play an important role in our erosion control measures. For example, the permissible shear stress on a turf reinforcement mat, I'll use P42, that's one we manufacture, but you know, it kind of holds true across the industry on this. Our permissible shear stress on that product is 14 pounds per square foot vegetated, but it's only 3.3 pounds per square foot unvegetated. That's a substantial jump in the strength and permissible shear stress on that product, vegetated versus unvegetated. Having vegetation long-term on our sites is vital. You know, the flow rate of vegetated to, or unvegetated to vegetated, I should say, 12 foot to 21 foot on that same product per second, on that same product. It isn't just a visual difference it makes. It is a truly vital part of our erosion control measures and the long-term success of those erosion control measures on our sites. So we know vegetation is important. We are actually trying to achieve it. And you know, what are our current practices? What does that look like for us right now? I think we'd all be familiar with this on the screen, right? You strip the topsoil and you stockpile it. Surprisingly, and I just met another gentleman yesterday on a job site in Austin, did not know that you were not supposed to pile topsoil higher than 4 feet, that the topsoil people will tell you not to do that, or you start to compress out your pore spaces, that you're supposed to be turning it regularly. And that means more than just once every couple of years. That means on a regular basis, you're supposed to be turning those piles. Well, those two things, one, we know we're not doing either of those. And even if you were, the topsoil people tell you you will lose 40% of the quality of that topsoil by stockpiling it for any length of time. And that's measured in months. And often our stockpiled topsoil stays there for years. Even if you had good quality soil on that site at the beginning of the project, by the time you go to spread that soil back out, most of the value would have been leached out of it or compressed out of it. So it'll be a very different product when you go to put it back down. Now, as you can see in the picture, we compact the ground. We know that's reducing our open pore space, reduces air and water exchange. Some bits of this are inescapable in the industry, but we do sometimes get in our own way a little bit with some of these things. Haul and spread whatever that topsoil was, or we buy it and bring it in if we don't have quality topsoil to begin with. And then we apply our seed fertilizer erosion control. My favorite part is sometimes we irrigate it, sometimes we don't. And how is that working for us? We know that it's working about as well as this shows. I think probably somebody on this webinar has somebody in their office or has it in their office themselves. I've seen this up in office after office. And yet, that is exactly what we're doing on our job sites. We know that technique from that previous screen isn't working well for us. And we keep doing it over and over again. Now, if we want to get successful vegetation, if we want to get sustainable vegetation, looking at that technique is probably the first thing you should do. Really, you should stop treating your soil like dirt. It is not something you can treat however you want and still have good results from it. We put so much attention in picking the right seed mix, the right fertilizer, the right erosion control, and we completely ignore the soil on our site. Now, there is an interesting saying in the horticulture industry and gardening. I came from horticulture before I ever came to erosion control, so this one was familiar with me, and that's, don't put a 50-cent plant in a 5-cent hole. You're supposed to flip that. You put a 5-cent plant in a 50-cent hole. You're supposed to pay attention to the soil. You're supposed to make sure whatever you are trying to plant and grow has quality soil to survive into. Our plants have no way to do anything except shelter in place. They can't move, right? They have to stay exactly where we plant them. How do they shelter in place from heat, from cold, from drought, from torrential rain? They shelter by having the soil that they need supporting them. This is a vital part of vegetation success. And as an industry, we have not historically paid a lot of attention to this part of it. That's not saying we ignored it completely. We knew it was important, but did we really throw the parts and pieces at it that we needed? We tried, certainly, and I think this topsoil spec illustrates that. I mean, this is an attempt to try, right? Now, I am based out of Central Texas. This is the DOT spec I am most familiar with, but this type of spec holds true across the industry, regardless of where you are. They all look fairly similar to this, really. And if you look at that, it looks good. It looks like we're trying for the right thing, and that's easily cultivated, fertile topsoil, yes, right? Free from objectionable material, ideally, yeah. High resistance to erosion, that gets a little fuzzy. Able to support plant growth, yes, that's the total idea. The only problem on that spec is that there is truly nothing measurable for that. How do you inspect for that in the field? It's an attempt that doesn't really get the results that we need. but we tried. That was our attempt in the past for that. You know, and that attempt that doesn't always pan out for us, that doesn't have measurables that tell us, yes, there's marked improvement on that product, that is costing us a pretty penny. Here's the average low bids. This one is Oregon. I pulled a couple states to look through on this, and you can see 3 inches of topsoil, almost $19,000 an acre. 4 inches, almost $25,000 an acre. You know, you look at Michigan, you toss the high and the low, which you should always do, but seldom do I see that happen. But if you do that here, $15,000 an acre on 3 inches of topsoil, $23,000 on 4 inch. This is an astronomical expense that we're paying for a product we really don't know if it's any better than what we have existing. That is not measured by how much improvement it brings to our site. And that's interesting, because if you really break down what topsoil is, you learn a few very vital facts here. And that's, if you look over on the left-hand side on the horizons of that soil column, you'll see that the O and the A horizon, that is what we consider topsoil. It is the darker in color dirt at the top. Color isn't the benefit we get, right? But it's that darker in color, as you can break out on the right-hand side, by what is it composed of. Interestingly, 50% of it is just open pore space. 45% of it is inert mineral material. That is the exact same thing and makeup as your lower horizons in that soil column, as your subsoils. Only 5% of topsoil, and please note that is in the very best topsoil. Often they have less than that. In the very best topsoil, you have 5% organic matter. That accounts for that darker color, but the true benefit comes from the increase in the cation exchange capacity that's found in that organic matter. That's how much nutrient capacity does that soil have to hold on to and provide to the plants. In that organic matter, that 5%, that's where the entirety of your soil life is. That's your mycorrhizas, your bacteria, your molds, your other types of funguses, microorganisms. Those all are in that area. A majority of your water holding capacity is in that 5% as well. So it's really interesting when you think back to the slides a second or so ago about the expense that we are spending to bring in this topsoil, the effort involved in it, and what we really need is only 5% of that, and that breaks out like that. If you only need 5% what's in all the rest of those trucks bringing in topsoil, that's only a half truckload of material. And remember, that's in the best topsoils. This is a project I worked in from the Rio Grande Valley here in Texas. And you know what? Not every place has the very best topsoil available. There actually is not enough quality topsoil to go around and cover all of our sites. So sometimes we have to make do with substantially less than the very best topsoil available, and this illustrates that. Now, they paid a pretty penny for this. This is a soil test on the topsoil that they were able to find and bring into that site. They sourced the best they could find, and they had 0.8 organic matter. That is classified as very low, and this was on the topsoil they brought in on that site. Existing soil on that site was 0.5%. An tiny, just infinitesimal improvement for a vast expense on that project. But it was the best topsoil they could find. They were handcuffed for that. To their mind, they had no other options. But the question needs to be asked, if we're adding topsoil to add that organic matter and all the benefits that comes with it, but organic matter is less than 5% of topsoil. Could we just add that 5%? Could we add the organic matter? Could we add the soil life and achieve the same results? And so that's what we asked in developing this product category. It has been over 10 years, but 10 years ago, the owner of this company asked, like, could we do it a different way? Do we have to import topsoil or compost to get that organic matter? Or could we add the organic matter itself? Could we do it in a way that's easily inspectable? Could we do it in a way that's prepackaged, that's easy to mix, has very little room for operator error in the use of that? Could we do it in high capacity loads? Could we increase our productivity by adding that organic matter instead of all the rest of it that we didn't need to import on that site? And what sources of organic matter are available? If we are going to be doing that, what are we going to be adding? And I think the first one that everybody thinks of is compost. I'll garden, it's concentrated, you know, it's what I use on my roses, right? There are some drawbacks to compost, though, that we need to consider. This image on your screen on this slide, this is a municipal composting facility. And this one's actually in Las Vegas, and I am positive that smells wonderful. But it illustrates a point I want to make about municipal composting facilities. One, these would be the only ones that have a large enough volume to use on our construction site, so this would be the compost that would be available to us. But it illustrates the point, and that is that they get huge volumes of source material in and move huge volumes of finished goods out. And while they do check for contaminants, they just don't have the capacity to check for every possible contaminant that could possibly come in on their source material. They try, they do quite a good job, but again, they can't catch everything. And that means, you know, by its very nature, compost does nothing except concentrate down. It concentrates down the nutrients found in the source goods into the finished product, but it can also concentrate down any possible contaminants. And when we talk contaminants, we're talking about salts, heavy metals, fungicides, pesticides, herbicides. There's a wide range of possible contaminants that can pass through into finished compost, and that is not a theoretical problem there. That has played out in the real world. Excuse me, I have my dog in my office with me, and he's growling at something outside. I hope y'all can't hear that. That is not a theoretical problem. That has played out in some pretty catastrophic crop losses in California. And that was a few years ago. And when they went through to find out what was the cause of those crop losses on those agricultural fields, they found it was because the municipal compost that had been spread on those fields had been contaminated by common dandelion herbicide. They had basically spread herbicide on their entire fields that they were trying to grow crops in. So it's not a theoretical problem. Certainly it is something that we have run across in the real world. It's not only possible chemical contaminants. It can be weed seeds or pathogens even as well. So this project right here, this is a project right outside of Austin. And do you think that they wanted the bluebonnets on that project? Or do you think they wanted the bastard cabbage that came in on the compost they used on that site? This was and continues to be a significant expense. They are still attempting to remediate this site. It has been multiple years. I think they're coming up on 3 or 4 now, and they are still dealing with this issue. And they imported their own problem onto that site by bringing in that bastard cabbage. Weed seeds can pass through compost. If you ask the compost people, they will say, under ideal conditions, composting will kill weed seeds. That is under ideal conditions. If you pile up your pile of compost too high, it actually reaches too high of a temperature and will kill the microorganisms in charge of the composting process in the center of that pile. If you don't pile it up high enough, it actually won't reach a high enough temperature and kill the weed seeds. So that is under ideal conditions, it will kill weed seeds, but who knew that piling up trash was a pretty exact science, but it turns out to be. So also a concern to consider. So Yes, compost is a source of organic matter, but it's one that does have some drawbacks associated with it. The other one to consider is peat moss. Now, one, just about every other industry that grows plants as part of its business model uses peat moss as the organic matter. Why do they do that? Well, it has a very low carbon to nitrogen ratio. That means it does not pull a lot of carbon out of the soil as it's broken down. So it leaves that nitrogen available for plants to use. It has a very high cation exchange capacity. That's what I was talking about earlier. Your soil, your organic matter's capacity to hold on to nutrients and not have them just leach out of your soils. It has an insanely high water holding capacity, over 1,000%, 26 times its own weight. And it's very long lasting in soils. It's important, especially when you consider compost is very short lived in soils. It is a product that is mostly broken down and continues to break down at that rate. Compost, we all know, has to be reapplied every year, every other year. Peat moss does not. It has a very strong cellular structure. So it's very long lived in our soils. But, just reiterating, peat moss can hold up to 26 times its own weight in water. Think about that. I mean, that's 1 pound of water results in 26 pounds of water holding capacity, so quite substantial. When you think about adding it to your soil, if you use an application rate such as in our product, that's almost 7,000 more gallons of water holding capacity in our soils. It's basically equivalent of tossing one of these every acre. Now, there are some misconceptions about peat moss. One of them is that it's not an environmentally friendly product to harvest. Now, I think some of the bad press associated with peat moss comes from Great Britain, right? In Great Britain, they were not sustainably harvesting their peat bogs, which also were much smaller than the North American ones. So they had a much smaller, ecosystem, right? They were harvesting it in a way that was degenerating it quite quickly relative to the side of the bogs. And they were burning it as a fuel source. So, this is years ago, but so they were burning it. You take carbon out of the ground, you burn it, you release it into the atmosphere, you're degenerating the bogs. The bogs aren't able to renew themselves. Every bit of that is bad news. Luckily, there is not one bit of that that is how we're doing it in North America. So North American peat bogs are massive. If you start in Alaska and you fly east, it'll take you about 17 hours to get to the other side of them. Less than 1% of those bogs are under active harvest every year. And they're harvested in such a way that they are able to regenerate. And they do it 3 to 6 times faster than aspenwood forests are able to regenerate. And that aspenwood is considered one of the most sustainable forestry products. Also, in this instance specifically, we are using that product to grow vegetation, to lock up more carbon in our soils. So there really is not a concern as to how we're harvesting or using North American peat. There is another component of all of this. If we use that as the source of our main organic matter, and that's our soil life, right? Soil is alive, dirt is not. There's a big difference, and soil is what will actually sustain our plants. Now, bacteria, soil bacteria, that is the first one that I think all of us think of. That is the shredder bacteria that breaks down organic matter into usable nitrogen, phosphorus, potassium. We're familiar with those bacteria. There are other soil bacteria. This one on your screen right here, this is the nitrogen fixing bacteria. This is the exact one that makes your grass green up after thunderstorms. It is one of the most vital to have in your soils. It is also one of the most prevalent in our soils. And so, surprisingly, it is one of the first to degenerate out of stockpiled topsoil. So it's a vital one to have for our success. This, like I was saying, is the shredder bacteria that breaks down leaf litter, roots into usable nutrients. Now, there's another part of soil life, and that's one we are generally less familiar with in the industry, and that's mycorrhiza. And mycorrhiza is a symbiotic relationship that forms a relationship with plant roots. The interesting thing is how extensive those systems are. Now, the pine tree sapling you see in the center of your screen, if you see those kind of orange roots right in the center, that is the extent of that root system. Everything else that's radiating off of that is fungal hyphae. That is not the root system. That's actually the fungus that forms that symbiotic relationship. And it's a good illustration of how much that relationship and that fungus increases the water and nutrient uptake of that plant. It's vital for that plant's success. 90% of plants on the planet require that relationship, that symbiotic relationship, to be formed with mycorrhiza to thrive. We will never get our plants to where they are fully expressing and successful if we don't have this relationship established. There's one more thing that I like to draw attention to, and that is those two things are vital, the organic matter, the soil life. It's also even more important as we see our designs start to transition in the industry. We know drought-tolerant plantings are important. We are transitioning to a more prairie mix, a more native planting on our sites quite often, right? And they handle differently. They don't require such high doses of fertilizer. Fertilizers actually are a detriment in such plantings because all they do is pop the weeds very quickly. Some of these are slower germinating. Some of them take longer to get established. If you throw a triple 15 fertilizer, they're not even germinated by the time the weeds are using that fertilizer. So we got to fertilize those plantings differently. We also have to water them differently. They generally don't like high doses of supplemental watering when they're established. So that's great because as an industry, we do not want our sites to be pets. We don't want to be feeding and watering them regularly. We want to plant them and set them free. We want them to be able to sustain themselves. We cannot do that if we're designing with native and drought-tolerant mixes, but installing them or maintaining them under the same techniques we're using conventionally. So something to consider there as well. Now, all of that was, call it about 30 minutes of background before I actually even get into really talking about our product. Yes, it has a peat moss base. There's what we were talking about. This is our product. 60% sphagnum peat moss. That's your organic matter, water holding capacity, all of that. Inoculated with mycorrhiza and bacteria, multiple species of each. To get established, to have that soil life, to form those symbiotic relationships. There's some growth stimulant in there. There's some micronutrients. And I know you're looking at that and going, you skipped one. And the interesting thing is that a lot of people think that 40% straw and flexible flax fiber is filler. I actually think it's quite a lot of filler for it to be 40% of the product. It is not a filler. It would be just, it costs just as much to produce if we made it entirely out of peat moss. But what we have found is that straw and flexible flax fiber is a food stock for that mycorrhiza and bacteria. You got to remember, mycorrhiza and bacteria, they need active plant roots. They need that colonization. Well, if you're installing them, if you're installing them on your job sites at the same time you're planting the seed, you're throwing them into a desert. There are no existing plant roots there. So as that first season progresses, as your plants are getting established, those colonies of mycorrhiza and bacteria need something to survive off of. That is what they survive off of, that strong, flexible flax fiber that is a food stock for those. So by the time your site is vegetated, by the time it has germinated, you're getting to 70% cover, you have active roots moving into the soil, those colonies still exist to be able to colonize them. Is vital to have if you're going to have those colonies succeed through the installation process. Now, where are you going to use it? You're going to use it where there's minimal to no organics. We know good topsoil has 5% organic matter. If you have less than that, you're going to have a benefit to the use of a product like this. Little to no soil structure or where it's been mishandled. Like I mentioned, if you had good topsoil, but it's been stockpiled for 5 years, you're going to need to reintroduce that soil life and some organic matter to that through the use of a product like this. Where an increase in water storage on your site is important. Also to allow for a reduction in supplemental watering or an increase in the success of the germination and sustainability of that plant. But that's important. All of those would be what you would check off to see if you need the use of a product like this or not. Now remember, I showed you this soil test before. This was on the topsoil they were able to buy. This was for a TxDOT project in Mercedes, Texas, and that's 0.8% organic matter. That looks like this. It looks like pure sand, really. And remember, that was the topsoil they were able to source and bring in on that one. Now, this project was interesting. That was a new roadway that was put in. It was actually expanded, I should say. And when they expanded it, that slope starts right at the edge of that road and runs straight down, straight to the fence on private property. This was vital that they not have erosion control issues on this site. So on this project, this was our first test shoot with TxDOT, and our product was applied straight over the top of their topsoil. Your seed is applied with it, and then there was erosion control over the top of that. It was a double net straw blanket that was used on this one. Now, they did a side-by-side comparison on this project, and I think you can see where that line was between where our product was applied and where it was not. And it is a sharp line delineating where the use of our product was and where it wasn't. You can see it's right there by that guardrail. Now, this was an astronomical achievement on the vegetation on the site, because this was also a test for them on this site with no supplemental watering or fertilizer after installation. It was also seeded in July. It was insanely hot. It was outside of the normal seeding window for the area. And so seeded in the very worst season with no supplemental watering after installation. And those were the results they were able to achieve. A full year later, that site has vegetated so well and so thoroughly and so densely that TxDOT in District 21, which covers the Rio Grande Valley, has put this product in their design manual. I have highlighted that in red just to make it easier to read there, but they are recommending the use of a product such as this to the topsoil in areas that have steep or lengthy slopes that might be susceptible to erosion. Should also be used in other areas where it is known to be difficult to establish vegetation. The design engineer for that district laughed when he sent this to me and said, you know, that last sentence, that's their entire district. It might as well be their entire district. They have not achieved vegetation results like that before. That is definitely not the standard. They have a history in the entire district of having difficulty establishing vegetation. So now they are designing their projects with the use of a product like this. You know, I made mention to it earlier, but we have actually been in the industry for quite a long time. This product, in its finished formulation, has been on the market for over 10 years. Now, when you're selling a product that is designed to promote vegetation long-term, it's nice to have decade-long case studies to back that up. And this is probably one of our best-known case studies. This is a site called Milner Ridge. This is actually in northern Manitoba. And you can see, thanks to glacier action on that site, that just looks like beach sand. dune sand there. You just pick it up and it'll blow away out of your hand. They had very, very thin layer of topsoil over the top of that. There was actually no reclaimable topsoil on that site. It is quite remote also, so to bring in topsoil was an astronomical figure on the site. It was over $500,000 on the topsoil bid. Now, use of this product on top of providing improvement over what topsoil can provide also provides a substantial cost savings over that topsoil. When we saw on those slides earlier, the expense topsoil can improve on an acre basis. On this one, it was $500,000 on the topsoil for this site. The use of biotic earth in the place of that topsoil saved the owner on this project $270,000. It was less than half the cost of the topsoil on this one. Now it does, it's a good illustration here. It does apply through a hydromulch machine. It is hydraulically applied. Even though it's hydraulically applied and we're used to everything that's applied hydraulically being erosion control, remember, it is just soil improvement. In this instance, you will still need erosion control over the top of it. So in this instance, you can see in the background, they're using straw blankets as erosion control. You can also use a hydraulically applied erosion control as well. That up on the screen there, that is the ideal application rate. That's our recommended rate. That's 3,500 pounds. And we actually did test plots on this exact site out on Milner Ridge, testing everything from an application rate of 1,500 pounds through 10,000 pounds. And there's no detriment to applying it heavier than that. We just found we stopped seeing any benefit to applying it heavier than 3,500 pounds. So we know that is our ideal application rate. Here's initial germination on that site. You can see it's coming up through the straw blankets. Here's 13 weeks later, and I think we would all be very happy with those results at 13 weeks. But I'll make the point that there's something you don't see here that you also don't see an entire year and 2 months later, and that's weeds. The only thing you see on that site filling up that available space on that site is the plants that they want established there. Now, I'm not saying that weeds will not make their way onto this site through birds and animals and wind, but we didn't import the problem at installation. We didn't bring in weed seeds in a product that wasn't weed-free. You know, these biotic soil amendments, our product is weed-free, not importing that problem at the time of installation that you then have to worry about remediating later. Now, like I said, we have had this site installed for over 10 years now. We go back every year and take follow-up pictures. We know it is still being successfully and sustainably maintained all these years later. Oops, I just kicked myself out. And yet a couple years ago, we went, well, let's see what's actually going on under the soil surface there. I don't know why that did that to me. And these were the results. So Milner Ridge A is where our product was applied. Milner Ridge B is the control on that site. And you can see, you know, even that many years later, your bacterial counts, your yeast counts, your mold counts are substantially higher than they are in areas where a product was not applied. We know that those colonies of soil life maintain at such a higher colonization rate through the use of our product. Here's an interesting site. This is a different one, and it's the other end of the planet. This is Mission Reach project. It's one of the case studies I have put in as a handout for you to be able to download. This is a San Antonio River Authority project called Mission Reach. The interesting thing about this project, and the reason I share it, is that on this site, we had, quote unquote, good topsoil. There's no possible contaminants in it. It was a very good quality, 5.7% organic matter. It actually was the highest organic matter I've ever tested in any of the soil tests that I've been doing. And yet, these were the results we achieved. They wanted to see us side by side. So These two sides of this project were seeded at exactly the same time, with exactly the same seed mix, and covered with the exact same flexible growth medium as their erosion control. And yet you can see the stark line over where vegetation had established and expressed itself and where it hadn't. It took almost a month longer for the side without our product to catch up. And, catch up it did. Here you can see that site now. It's incredibly lush. But the other side sat completely bare for almost a month before it vegetated and caught up to the other site. And so this is from the landscape superintendent there. And he gave us a recommendation on the use of biotic earth with a native seed mix. And that was a native seed mix. We were able to get germinating that quickly. That first side by side, that was 3 weeks after installation. This one. That was achieved 3 weeks after installation. It was installed in the summer. It's nice and warm, but still, that's good growth to achieve in such a short period of time. And, they are recommending the use of this product where they found the initial germination was much higher. It had less weed competition and higher diversity of vegetation with greater germination of native species compared to the adjacent area without biotic earth. It was a very successful project, and so I would say there is a place for a product like this. Even on good soils, there was still a huge benefit to the use of a product like this. Even on areas where there are quote unquote no soil. Here's a green wall application. This was an interesting one. I also put this case study in the handouts for you. And that is the Deset green wall system. So on the top of this green wall is a roadway. And you can see on the left-hand side, on the other side of that silt fence is a protected wetland. Not a lot of space there. Now, the green wall was used in this instance, one, because that vegetation down that green wall does provide some capture of possible contaminants to that protected wetland, but also because due to the proximity of that wetland, that footing couldn't be, had to be adaptable on the site. Hardscapes are not very forgiving aesthetically if there are adjustments having to be made like that. But with the green wall system, they were able to minimize the effect of that on the aesthetic results that were achieved. Now on this one, that gabion wall there is filled with 3 to 5 inch riprap. That is riprap with fines. This isn't perfectly cleaned rock, not rinsed rock, right? It's 3 to 5 inch. It did have some fines. Our product was applied, just sprayed directly into that green wall system. And then a bonded fiber matrix erosion control, just to kind of stick it in place, was applied over the top of that. And these are the results that they achieved on that site. Years later, it is still a successful green wall system. And that is hard to say in this industry. We see projects with products like this, or cellular confinement, green roofs, grass paves, all of those, to be successful, have to vegetate successfully. And that's where some of those have fallen down in the past. Where we're able to achieve that through the use of really paying attention to supercharging, as it were, the small volume of soil that's available in those systems. So use of a product like a biotic soil amendment in conjunction with those products would be beneficial. Where you have a high visibility project is also important. This is a new project in the design phase that hasn't started yet in San Antonio for Hardburger Park. This is going to be a land bridge. That site, regardless on if it's aesthetic on the hardscapes, would not be deemed a success if the vegetation on that land bridge was not successful. It's a small amount to pay to make sure that your vegetation is successful on that site. I'm going to leave on this slide as well. This is a roadway. This again is northern Canada. And you can see the stark line again that I'm talking about, just on the existing soils where the use of our product was right next to that roadway and where it was not. The results in the vegetation that they were able to achieve. So I did see we had one question come up, but for some reason I couldn't open it earlier without kicking me out of my slideshow. Is it being recorded? Yes, yes it is. So you'll be able to hear my dog bark in the center. I will share the link to this recording if anyone wants that. I'll make that available. You can just email me. My email is Lauren, Lauren, at ECB, that's Echo Charlie Bravo, .ca Charlie Alpha. I will throw it open to any questions. You can type it into the question field or into the chat field, and we will get that answered for you. See, I have a hand up. Let's see. Looks like Christopher has his hand up. Let me see if you have a headset on. I can unmute you. And you can... Christopher, are you there?
I am, yeah, thank you. We work in northern Canada. I'm wondering what restrictions there are to application in cold weather.
You know, that is a good question. It mostly is dependent on your seed mix. There certainly have been in Alaska. I'm thinking of one project in particular that was done on a ball field up there, where it was seeded just 3 weeks before they got snow, and their heavy cold weather really hit and kind of shut them down for the season. That was considered a cold weather, a dormant application, basically. More than anything, you're not going to be limited by any restrictions on the biotic earth, but by your seed. Do you run the risk of that seed germinating and then getting killed by cold weather? Is it already dormant with no risk of that and can be applied and then wait under the snow cover and germinate in the spring? So more an issue that you're going to run on your seeds that you're going to plant with the biotic earth than with the biotic earth itself.
Very good, thank you.
All right, thanks. Does anybody else have any questions? Let's see. Do you ever, looks like Devin has a question. Do you ever disc in a layer of biotic earth and clay soil sites to incorporate and provide a deeper root? Certainly it could be done. Certainly if it's very compacted soils, especially on clay, if you're looking at a really hard pan surface, you have to remember your roots still have to incorporate into that. What I see more often than disking it in after the biotic earth is applied is some kind of scarification on the soils before it is applied to rough up that soil surface ahead of application of the biotic earth and the seeds. So certainly can be a benefit, not always called for, but definitely if you have that kind of hard pan soil, would be a benefit to get that broken up a little bit before application. Let's see, we have a question here on mycorrhiza populations may differ throughout North America. How applicable is the mycorrhiza that is in the project for all regions? And that's a really good question. We have what we consider a prairie mix, so it's multiple species of mycorrhiza and bacteria in that. Those colonize across, as you've seen, from northern Canada and Alaska all the way down to South Texas. Those are able to colonize those climates because there's such a wide range and variety in there that some may thrive and some may not, but you still have some that'll thrive in all ecosystems. And it's a prairie mix because they will colonize on everything from grasses to annuals and perennials, as well as some woody shrubs and even trees. So you were covered on just about any climatic condition, geographic area, as well as plants you're trying to establish. There will be mycorrhiza and bacteria that will colonize with those. The only time you would really need a very customized blend of mycorrhiza that I have really run across is in areas with salt spray, kind of brackish water condition areas. And that was Alan who asked that. Does anybody else have any questions? Going once, going twice. Again, you can email me if you have any questions, or if you would like other case studies or some more information, please feel free to reach out. I certainly appreciate you guys attending the webinar. Thanks so much.